Okay, this is a limit that involves trigonometric functions as x goes to 0. Perhaps the first thing that comes to your mind is the interesting limit of sine x over x as x goes to 0, which is known to be 1. So what we will do is that we will try to link our limit to this limit by possibly multiplying by the conjugate. So this is the limit as x goes to 0 of 1 minus cosine x divided by x squared, and the conjugate of the numerator is 1 plus cosine x. We divide by the same thing, so as if we do nothing to this expression. And the reason why we multiply by the conjugate is that we will get in the numerator 1 minus cosine squared x, as it is the difference of 2 squared, and in the denominator we will have x squared multiplied by 1 plus cosine x. So the numerator is going to be only sine x squared, so this is sine squared x divided by x squared, and then 1 plus cosine x. Now the limit of sine squared x over x squared is equal to the limit of sine x over x as x goes to 0, and everything is squared, which is 1 squared, and that's 1. And the other limit, which is the limit of 1 over 1 plus cosine x as x goes to 0, direct substitution will give you 1/2. So now this limit that we have in hand is nothing but the limit of this times the limit of the other part, and that's 1 multiplied by 1/2, and the result is just 1/2. Okay, so this is the limit of x multiplied by sine 16 over x as x goes to infinity. The known result of the limit of sine x over x equal to 1 is only valid if x goes to 0. So this is different from this limit because x is going to infinity here. And if you want to relate them together, then we need to make a substitution. Substitution is probably going to be w is equal to 16 over x, as to create only a w as the argument of sine x, of sine, right? So now what happens to this is that if x goes to infinity, right, the plus infinity, then it is true that w will go to 0 from the right hand side, because 16 over a very large number is going to be close to 0, but it will always be positive. So now the limit as x goes to infinity of x multiplied by sine 16 over x will be equal to the limit. Now x is 16 over w actually, and you can solve for x here, and we have a sine w, and this is going to be true if w goes to 0 from the right side. So this is equal to 16 multiplied by the limit of sine w over w as w goes to 0 from the right hand side, but this is 1, and therefore the answer is 16 multiplied by 1, which is 16. Okay, here's a limit of trigonometric function, which can be related again to the famous limit of sine x over x as x goes to 0, known to be 1. In order to compare these two limits together, we need to make a substitution. The substitution we're going to do is w equal to 1 minus x. And the reason for that is that I want to create only one letter in the denominator. Now, as x goes to 1, we know that w will obviously go to 0. So this limit, the limit as x goes to 1 of sine pi x divided by 1 minus x, is going to read the limit as w now goes to 0 of sine pi, and x, you can solve for x from here, and it will be 1 minus w divided by divided by w now. Now it is known that that sine pi minus alpha is equal to sine alpha, and therefore this limit could be written as the limit as w goes to 0 of sine now pi minus pi w divided by w equal to the limit as w goes to 0 of sine now pi w over w. The reason why we cannot use the famous limit directly is because of the pi here. So we make another substitution, and the other substitution is going to take care of that pi. So we say that z is equal to pi w. Now as w goes to 0, also z will go to 0, and therefore this limit could be written now as the limit as now z goes to 0. This is the sine of z divided by w. You can solve for w from here, which will be z over pi. Now this is equal to pi, obviously the limit of sine z over z as z goes to 0, and this is 1, so the result is just pi. Okay, this limit can be split into two limits, of course, if both exist. We look at the first limit, and the answer is really simple. So this is the limit as x goes to 0. Take a common factor, so this is x minus 1. You can cancel the x because x is not 0, and then if you substitute directly, then you get a minus 1. Okay, now let's look at the second limit. The second limit, the limit of sine x squared divided by, if we take x squared as a common factor, this is going to be 1 minus 1 over x, and this is the limit as x goes to 0. Now here we will look into two different limits again, and these are the limit of sine x squared of x squared as x goes to 0, and the limit as x goes to 0 of 1 divided by 1 minus x. The first limit, by a simple substitution, given by w is equal to x squared, so as x goes to 0, also w will go to 0. So this limit could be written as the limit as w goes to 0 of sine w over w, which is the famous limit equal to 1. Now the second limit here, the limit as x goes to 0 of 1 over 1 minus 1 over x. As x goes to 0, this is going to be infinity, and this is 1 minus infinity, which is minus infinity. 1 divided by minus infinity is going to be 0. So now this whole limit now is equal to 0, and the answer, of course, you just want to subtract them. Minus 1 minus 0 is just minus 1. Okay, here's a limit that involves trigonometric functions, and what I want to do here is that I want to write the tan of 2x as the sine of 2x over cosine 2x to start with. So this is the limit as x goes to 0 of sine 2x, which is the argument. We have a square for the tan, so this is going to be square divided by cosine of the argument, which is 2x, and we have another square here. Now we also have an x here and a sine x, so this is going to be the limit as x goes to 0, and I'm going to expand sine 2x because this is just sine 2x square divided by cosine square 2x times x times sine x. So what is sine 2x? Sine 2x is nothing but 2 sine x cosine x, don't forget the square here, divided by cosine square of 2x times x times sine x as x goes to 0. Now this could be written as the limit as x goes to 0. This is a 4, that's a sine square cosine squared x divided by cosine square of 2x multiplied by x multiplied by sine x. Now a sine x will cancel with the square here, okay, and the result is going to be the limit as x goes to 0 of 4 cosine, just a small rearrangement, divided, and here's a sine x, and I have cosine square of 2x multiplied by x. Now you see that this limit is actually 1, and a direct substitution in here will bring 4 cosine 0. Cosine 0 is just 1, and in the denominator it will be also 1, so that's going to be 4 multiplied by 1, and the answer is just 4. Okay, this is a quick one. It's the limit of secant x multiplied by sine of cosine x as x goes to pi over 2. If you rearrange this expression as sine of the argument, which is cosine x, divided by secant x goes in the denominator as cosine x. So you have a feeling that this looks like a sine of w over w because the argument is cosine x. But if you directly substitute in here, you get a cosine of pi over 2, which is 0. Sine of 0 is 0. Cosine of pi over 2 is 0. So this is a 0 over 0 form. And let's just make this substitution as to make the argument as w. Now we know as x goes to pi over 2, cosine pi over 2 is going to go to 0. So w will go to 0. And this limit could be written as the limit as w goes to 0 of sine w over w, which is the famous limit that's equal to 1. Here is a limit that involves trigonometric functions with a little bit complicated arguments. This limit could be written as the limit as x goes to minus 2 of sine. Now I'm going to just factor what's inside as x plus 1 multiplied by x plus 2 divided by x plus 2. You can see the existence of x plus 2 in the argument of sine, and also x plus 2 in the denominator makes it probably possible to make this substitution. W is equal to x plus 2. So now as x goes to minus 2, we know that w will go to 0. So this limit now could be written as the limit w goes to 0 of sine. Now this x plus 2 here is just a w, and now x plus 1 would be w minus 1. That's it, right? And down here we have a w. Now this limit, of course, the sine could be expanded, so this is the sine of w squared minus w divided by w, which is equal to the limit of sine w squared cosine w minus cosine w squared sine w. Everything is divided by w. I've just expanded sine alpha plus beta as sine alpha times cosine beta plus cosine alpha times sine beta. If you have a minus sign, then the middle sign will just change. So this is the limit as w goes to 0. Now looking at the two limits individually involved here, so we're looking at the limit of sine w squared cosine w over w as w goes to 0. Now there's no problem with the cosine w because as w goes to 0, that's equal to 1. But with this w squared here and w, we need to do something. So we just define z to be w squared. So now as w goes to 0, we know that z will also go to 0, and this limit here is going to be equal to the limit as z goes to 0 of sine now z, and w is just the square root of z, okay, and this is just the cosine of the square root of z. Now if we just multiply up and down by the square root of z, so this is the limit as z goes to 0, we have the square root of z here, and then we have a sine z divided by z, that's the square root of z multiplied by the square root of z, and this is a cosine of the square root of z, If you look at now at this part here is 1, and this part is also 1, and as z goes to 0, this part is going to go to 0, so the whole thing is just 0 here. So this part has been resolved here, and we're only left with the second part, which is the limit as w goes to 0 of minus cosine w squared sine w divided by w. Now as w goes to 0, this is going to go to 1, and cosine of 0 is 1, so this is going to go to minus 1. And if you add the 2, then the answer is just minus 1.